Hi guys, good afternoon. So in the last session, we went with the subnet mask. We saw about IPv4 classes. We saw about subnet mask. And other than subnet mask, we saw about, different calculations for class A, B, C. Okay, like how many devices, how many IP addresses we are getting in a network, as well as how many networks we can design. Okay. Now the part that is we are going to cover today is about, first of all, we'll start with the private and public IP. Then we'll see about classful and classless subnetting. Okay. Then once we complete this part, today I'll be uploading few practice questions in your drive for subnetting. Okay, you have weekend to yourself, so you guys can practice, and Monday we can discuss. Okay. So first of all, let's start with the private and public IP. So what is private IP? What is public IP? Hmm. We can see like walking. Okay. Basically, you mean to say is public IP addresses can be tracked. Somebody can see or somebody can track your location using your public IP address. Okay. So you see here, first of all, let's talk about the differences between your private IP and public IP. Okay. Now, the first thing is why your private IP concept, why we are able to use these private IPs. Okay. Because the number of IPv4 addresses are limited. The number of IPv4 addresses are limited. So how many total number of addresses in IPv4? So we say 32. That's 4.29 billion. You can call it 4.3 billion also. 4 point, or the better way to say is what 2 raised to power 32, which is equals to somewhere around 4.29 billion. Then if we see, so are there only these many devices in the entire world? No, right? Because if we see like today, everything is smart. Your TVs are smart, your watches are smart, your refrigerators are smart, your geysers are smart, your washing machines are smart, your ACs are smart, everything is smart. That means they are connecting to the network. They are also connecting to the network. And since they are connecting to the network, they will also use the address. So that means one single home, if you count at number of addresses, so like every home will have 5 to 6 mobile phones. Okay. Then they will have, these smart devices, then Alexa devices, multiple devices will be there. So even in a single home also, you will have like 20, 30 addresses being used. Correct. So if we say that okay, 4.29 billion is what? What is the population of India? So where your 4.29 billion addresses will serve the world? Even if you give one IP to one person in India, also it is insufficient. Then how come 4.29 billion can serve the entire world? Not possible. Okay. So during 90s itself, okay, 1990s itself, the internet community, they started working on this problem that, okay, somehow we have to save the addresses. So what they did, they came up with few solutions. Number one, your IPv6, which has 128 bits. And 128 bit means larger number of addresses. Then second solution was what? Was your CIDR. What is the CIDR? Classless interdomain routing, or you can also call it as a slash value. Okay, it has different names: CIDR value, slash value, prefix length, prefix value. Okay, multiple different things are there. So basically, overall idea behind your CIDR is what? That rather than assigning one single network, we are dividing the network into parts and we are assigning a part of network. Your classless subnetting, which we are going to do today. Okay, so that was your CIDR concept. And the third one was your NAT concept, network address translation. So this NAT concept is there because of which we are able to use your private addresses. Without NAT concept, we cannot use. Okay, right now we are saying that okay, in my local network, I can use a private IP. But when I'll go to the internet, what I'll need? Public IP. So my private IPs, they are getting translated into what? Public IP. Who is doing that? Your NAT. This is what your network address translation is. Okay. Now, yesterday we haven't discussed about the CIDR and slash value, right? We haven't discussed it. So just make a note of it. Small thing it is. Your CIDR, prefix length, or you can call it your slash value. Okay. These are what? That you will be given a slash, and after a slash, a number will be written. What will be that number? That number will be nothing but your number of network bits. Number of network bits. So like if I have my subnet mask something like how many network bits? 8. So here my CIDR value will be what? If I have, it will be 16. For this one, it will be 24. This is, I think I'm using the wrong slash. This will be forward slash. Clear? Now let's talk about public and private address. Side will keep public, on another side will keep private. Now your public addresses. First of all, your public addresses, they are used on one side. That means over your internet, and your private will be used in the LAN side in your local network. Then your private IP addresses, sorry, public IP addresses, you have to pay for them. Whenever we are taking an internet connection, recharging our mobile phone for data, so we are also paying for the IP address. ISP will provide us an IP address, and these are free of cost. Then after, these are assigned by your service provider, or you can say your ISP. That means your internet service provider. And these are assigned by the network admin. That means you will be working as a network admin. You will decide that, okay, which IP address you will use. That are your public IP addresses. So these are assigned by network admin, or you can say local network admin also. That is also fine. Now, these public IP addresses, these are globally unique. These are globally unique. While these addresses, these are unique only in LAN. So from one local area network to another local area network, these addresses can repeat. That means if you have taken a Wi-Fi connection at your home and if your neighbor has also taken a Wi-Fi connection at your home, so you both might be using the same private IP addresses. That will not affect. Why? Because when you're going on the internet, so on the internet, your public IP addresses are being used and those are different for everyone. For an example, you can see here, let's say if I talk about my system, so if I say IP config, so right now in my local network, the IP I'm using is what? 0.36. But if I check what is my IP on the internet, so I can go to a web browser and I can say what is my IP address. And based on my IP address, it will, first of all, it is going to show me my public IP address. Let me go here and say, and let me see what is my. So if I scroll down, see what it says. This is my public IP address. So when I'm going to the internet, I'm using this IP address. This is not 0.36. And now, like I said, this IP address, with this IP address, anybody can track our location. Okay, so let's say if I go to this website, now this is showing something incorrect data. Okay, like it is showing somewhere in UP. But if you visit some other website, yeah. So they can reveal the location. Okay, and not just this. If you go, there are different tools. Okay, different websites will show you different data. Okay, so if I go with this website, ip2location.com, this might give me more information. Like, see, it says what right now where I am. And along with this, it is also giving me my coordinates. So now I can just put in these coordinates in the Google map and it will give me my location. Okay. So this way it can tell you then what is my internet service provider carrier. That means I'm using Geo Wi-Fi or Geo Fiber. Okay. So like that, it can give me lots of information about this. So this is your public IP address, which is globally unique. And your private IP addresses, they are unique in LAN. That means from one local area network to another local area network, they can repeat. Then after we have your public IP addresses. So you can say these addresses can be tracked. So anybody can track your location. Right now we saw, right, that anybody can track the location based on the public IP address. But with private IP address, since these can repeat, so there is no fixed location. Okay, so these cannot be tracked. And your public IP addresses, they are routable on the internet. That means with the public IP, you can use internet. But with only private IP, you cannot use internet if you don't have a public IP. If I'm not using any public IP and I'm just trying to use private IP for internet connection, I'll not be able to access it. Okay. So these are routable on internet. And these are not routable on internet. Am I audible to everyone here? You can come closer. Today I am having a bad headache. Okay. Severe headache is there. So I might not be able to speak very loud. What is routable? Routable means, let's say, for example, when we will perform routing, right? So you can basically you can understand simply like this only, that with the public IP address. Right now I'm having this public IP address here. This is my public IP. Because of this public IP, I am able to use internet. Because whenever, let's say, for example, I'm accessing internet, so my system will be sending a request. So right now that request is going via this IP address. So my destination, my service provider and everybody, they know this address. They don't know my 0.36 address, right? So if I will use 0.36, they will never reply me. They will never reply me, or they will never forward any packet to me, because private IP addresses, they can repeat from one LAN to another LAN. How they will come to know that, okay, to whom they have to send the packet, right? So for that reason, we say that your private IP addresses are not routable. You cannot have traffic replies based on private IP addresses. Only public IP addresses can get you the communication over the internet. Is that clear? So these are few of the differences between your public and private IP addresses. Now, for in each class, we use three classes: class A, class B, and class C. So in each class, a specific number is reserved for private addresses. Okay. So I'll create a table here. I'll say class, then I'll say number of private networks, and private IP range. First of all, class A. In class A, one network is reserved for private. The range, this is the range. In class B, 16 networks are reserved. Okay. The range from in class C, not like that. 256 are reserved. Hmm? 70. See here. If we talk about class A, only first octet is network. Is it changing? That means only one network. Class B, this part is network. Is it changing? Why not? From 16 to 31, it's changed. From 16 to 31. So how many numbers? 16 to 31. 16, because when you're saying 15, you're not counting the 16 itself. If you count like this, 1 plus 5, 6. So if I will say starting from 1 and going till 5, you will say only 5 is there or 6 numbers are there? 1 to 6. 1 to 6, 5 numbers are there or 6 numbers are there? Okay, imagine it like this. Try, like if this range was something, okay, 10 is not working. If this was something like this till 172.6, how many you would say, 5 or 6? 6. Then this also 16. This also 16. Because you have to count 16. After 16, you have 15 more. So this is one network, and after this, 15 more are there. So total 16 networks are there. Then in case of class C, 3 are there. So you can see going from 0 till 255. So total 256. This is how it is. Okay, so there was a task for you to check about classless and classless subnets, classful and classless subnetting. Did you check? What is classful? What is classless? Mhm. That is FLSM and VLSM. That is FLSM and VLSM. And those are two approaches used in the classless subnetting. Okay. So first of all, let's talk about subnetting. What is subnetting? Subnetting is the process of dividing a large network into multiple smaller networks. Okay. Why? Because we want to reduce the wastage of IP address. Okay. So how it is helping us? Understand? Like normally if we say, so we just have three classes for assignment. Okay. We just have three classes for assignment. So let's say if I go with class A, I know that how many IP addresses I get in one network? 2 by 24, which is somewhere around this many. In case of class B, how many IP addresses I get in a network? 2 by 16. Okay. And in case of class C, 2 by, which is equals to 2. These are the options I have. Now imagine, as of now, my requirement is what? Let's say I have a department and my requirement is like 50 systems, 50 IP addresses I need. Now, what is the smallest option I have? Class C. So in class C, in one network, how many IP addresses I'll get? Out of them, how much I will be using? What about remaining 200 addresses? Waste. Okay, this is still fine. What if my requirement is 500? We have to go to class B. In class B, how many I'll get? 65,536 addresses. How many I'll be using? How much wastage will be there? And if total addresses are 4.3 billion and somebody start wasting 65,000 addresses, right? Not a very good idea. That is the reason that they decided that, okay, we will not give entire network. If we give entire network, this is the situation. Rather than giving entire network, we will give a small part of a network as per the requirement. So that is what your subnetting process is. Clear? Now we have two subnetting approaches. So one is classful and second one is classless. So in classful, what will happen? You will use default subnet mask. You will use default subnet mask, and in classless, you will use non-default subnet mask. Okay. So that means if I say, like, if I give you an address, this is classful or classless? Hmm? Classless. How it is classless? Tell me how it is classless. Which class IP address it is? Which class IP address it is? Class C? A? CIDR value for which class? The CIDR value is for which class? . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . We just checked, right? A only. So isn't it the default subnet mask? It is default. So this is class proof. If I say this is also default. Also, no. Why? So which class IP address 192? Class C with class C default, right? So if when you're using class A subnet mask with class A IP address, class B subnet mask with class B IP address, class C subnet mask with class C IP address, this is all default. Anything other than this, non-default, classless. This is clear? Okay. So first of all, we'll go with the classful subnetting and then we'll go with the classless subnetting. Okay, so see in subnetting, in most cases, what will happen? They will give you with the IP address, a CIDR value, and they will ask you about network ID and broadcast address. This kind of questions will be there. For example, okay, this thing you have noted, subnetting definition. Note it down there. Yeah, only network bit it will give. Noted? Now, let's say first thing is given to you, like one IP address is given, or just take example of this IP address itself. This is given to you. Now, based on this IP address, we have to know about the network ID and broadcast address. So can you tell me? See. Hmm? Okay, let me just explain once, and then it will be more clear. Okay. Although it is right, whatever you said. See here, according to this /24. So according to /24, what do I came to know? How many network bits? After slash, we write network bit only. So 24 network bits. How many host bits? 8 host bits. This is clear. Now, according to this, we know that in subnet mask, network bits we write with 1, host bits we write with 0. All the ones on the left, all the zeros on the right. So that means how many ones I have to write? 24. And how many zeros I'll write? 8. So I'll say my subnet mask. From here will be what? Correct. Now from this, can I say in this octet, I have full network bits only? Second octet also? Third octet also? Fourth octet? We also know that in a network, we keep network part as constant. Host part, we start from 0 and take it to maximum. When host part is 0, network ID. When host part is maximum, broadcast address. Correct? Okay. So I came to know that, okay, network, and so that means out of this IP address, 3 octets I have to keep constant. So I'll say this is my 3 octets constant. And for first IP, 0. And the last IP, 255. And in between, if you want to see valid addresses, then this will be 10.1. This will be 10.254. And the first address, we call it as a network ID. This will be first valid IP. Okay, these are all valid IP addresses. So this is the first one. So we can call it first valid IP. This one will be my last valid IP. And the last address is what? Broadcast address. Okay, this is clear. Okay. So like this, just by looking at the IP address and CIDR value, we can calculate. See, and even IP address doesn't play a role. All the role is played by your CIDR value. Because based on CIDR, I was able to know that, okay, 3 octets I have to keep constant, 1 octet I have to start from 0 and maximum. So this was all on behalf of your CIDR value. So whether it is classful subnetting or classless subnetting, do not focus on the IP address. Just focus on CIDR. CIDR will give you the right answer. Let's say I want to calculate the same thing for class B. This is for class C. Let's do the same thing for class B. Although by looking at the CIDR itself, you can directly tell. So here, the same kind of calculation you would do. That okay, according to the CIDR 16, network bits 16, host bits also 16. So that means my subnet mask 16 ones and 16 zeros. Clear? Now, according to this, I can also say network, network, host, and this is also, that means network, network, host, and 2 octets I need to keep constant. 2 octets I will start from 0 and take till 255. These two constant, these two 0. And last one will be what? And in between, if you want valid addresses, you can keep. So 0.1. Today it will happen. Okay. Today it will happen. I'm trying to focus, but today it will still happen. Network ID, first valid IP. Then we have last valid IP. The same thing we can try for class A also. Based on /8, network bits 8, host bits 24. That means in the subnet mask 8 ones and 24 zeros. Now from here we can see network, host, host, and one is network, host, host, and host. So that means this I have to keep constant and host part 0. This I have to keep constant and host part maximum. Now I can have valid IP and 001. This will be 10.255.255.25. Again, your first address, network ID. We have first valid IP. We have last valid IP. Then we have broadcast address. Any doubt in this part? This is your classful subnetting done. Classful is easy. Okay, you don't need to make all this calculation also. Just by looking at the IP address and CIDR, you can directly give the answer. This is your class A. This is for class B. Okay, so classful is clear. Then we'll go with the classless. Okay, this is classful. Now let's talk about classless. So in classless, what do? We use non-default subnet mask. Okay. So like for example, first of all, if I talk about a class C address, so earlier one address was given to you 192.168.10.1/24. But if I use 24, this will be classful, right? So instead of 24, let's say I'll make it 25. Now what will happen? First of all, network bits. How many? 25. Host bits will become how many host bits? If your network bits increase, host bits decrease, because total bits we have 32 only, right? So this will be what? 7. So this time, how many ones I have to write? 25. 24. This one is 25. And remaining 7. This is clear. Okay. Now, if I see here, network, 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 but in this one, I have network bit also, host bits also. And this octet where you have your network bit as well as host bits. This octet. What do you call it? You call it interesting octet. What do you call it? Interesting. This is the octet that is going to give you all the answers. Okay. So first thing you will do here is you will calculate block size of your interesting octet. So which octet is interesting octet? Fourth. From here, first, second, third, and fourth. Okay. Then you calculate the block size of your interesting octet. Okay. Block size of interesting octet. How do you calculate? 2 raised to power number of host bits in interesting octet. Only in interesting octet. Okay. Number of host bits in interesting octet. So what will be my block size? 2 power 7. Okay. If I go 2 power 7, how much it will be? 120. This is my block size. Now the same rule. 3 octets are what? Constant. 3 octets are network, so I'll keep them constant. So that means This is constant. Then I will design my first network, and always we start from host part 0. So first network you will always start from 0. Then you will calculate the second network, next network, because this time we have broken down the network. Normally in class C, we get how many addresses? 256. But this time I'm getting what? 128. That means more than one network will be there. So if I want to calculate my next network, or before that, if you want to know that how many networks will be designed, if you want to know total how many networks will be designed, so if you say total number of networks, that will be 2 part number of borrowed bits. Number of borrowed bits. Now, what do I mean when I say borrowed bits? Normally, /24. How many network bits? How many network bits? 24. But this time, my network bit is what? 25. That means how many bits are extra? 1. That one bit you borrowed from which part? Host part. You converted one host bit into network bit. Okay. So number of borrowed bit will be what? 1. We borrowed one bit. So you will say 2 raised to power 1. How many networks will be designed? 2. One network you are already designed here, 10.0. Second network, how you will calculate? By adding this block size into your interesting octet. What is the block size? Which octet is the interesting octet? 4. Just add the value. This is your second. Okay. Now, if my second network is starting at 128, that means this network will end where? 127. This will end where? 127, right before that next network. So that means 192, 168, 10.127. Now this network, so after this, I don't have any network because only 2 networks will be designed. So that means this is my last network. This will go till maximum. So what is my maximum? 10.253. Now I can have the valid IP addresses in between 10.1, and here the first valid IP will be 120. Last valid IP here, and here last valid IP 250. Again the same concept. First addresses, network ID. Okay. Then you have first valid IP. Then you have your last valid IP. Then we have broadcast. This is clear. Okay. Now, what was the IP address given to you? 10.1? Yes or no? Here in the question, the IP address given was 10.1. So in which range it is falling? Between 0 to 127 or 128 to 255? 0 to 127. So that means for this specific IP address, network ID will be 10.0 and broadcast address will be 127. If in place of this, I had IP address 130, 150, that would fall in the second range. So network ID would be 128 and 255. Clear? This is clear. Now we can take some examples like this. Let's say you have been given with the IP address 192.168.10.150/25. Then what would be the network ID? And what would be the broadcast address? 128 would be network ID. 255 would be the first address. Same way, the address given to us 192.168.10.1/25 network ID broadcast address. So what it will be? This will be 10.0 and this will be 10.127. What if, let's say, like this is given? Then what would be the network ID and what would be the broadcast address? Not possible. What I said. Doesn't matter you're doing classful subnetting, classless subnetting, just focus on the CADR, forget the IP address. IP address can be anything. And in classless, this will happen. Any class, any subnet mask, doesn't matter. Just follow the approach. Okay. Follow the approach, you will get the answer. So do not say this is invalid or this is not possible. This is totally possible. Because see, again, CADR value is what? 25. This will be the subnet mask. You will design two networks. That means again 0 to 127 in the last octet, 128 to 255 in the last octet. Now look here, what is the value? In which range it will fall? 0 to 127. So that means your network ID will be what? 1.2.3.0. And this will be, because concept is same, 3 octets have network. That means you will keep 3 octets constant. Doesn't matter what is the IP address, we will just follow our approach. Is that clear? Okay, let's talk about another one. /25 and broadcast address. Network ID will be 128 and broadcast address will be 255. Just focus on the interesting octet. Interesting octet values will always give you answer. Here, no need to focus what are the values here. Your interesting octet was 4th octet. What is the value here? In which range it is falling? We are good to go. Is that clear? Online people? No, I can have anything 26, 27, 28. Okay, let's take an example. Okay. So let's say I'll directly give you one IP address. Okay. See, classless means what? This is one, just for telling that, okay, this is class C, I have given this. Otherwise, there is no class. When you're talking about classless, there is no class. That means when I say this, actually this thing is not valid. This thing is actually not valid. This is invalid because any IP address can be there, any subnet mask can be there. Your calculations will happen according to CADR. Okay. So let's say in the same place, I give you the same IP address. Let's say this time 10.45 I give you. And if I say /28, /28. So you have to make calculation now according to /28. We don't care what is the IP address. Okay. So how would you make the calculation? You would say network bits, 28 host bits, 4. Correct. Subnet mask. Right. So that means network, 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 and this one is interesting octet. 4th octet is your interesting octet. Now even you don't need to calculate the number of networks also, not required. Because eventually we just have to focus in which range this value will fall. That is it. So if I calculate, let's say, if I say that, okay, my interesting octet is what? 4th octet. So what I'll say, 4th octet block size. And what is 4th octet block size? 2 power 4, which will be 16. Now I need to design the first network. 3 values I need to keep constant. So what? 192.168.10 is constant. First value is 0. Next will be 16. Next will be 32. Next will be 48. Correct? What is my IP? 45. That means it will come in this network. So now I can say that, okay, I don't care about these also. No need to do all this much of calculation. I'll tell you a short method. Okay. But what I'm trying to say is you just have to focus on your IP address. And for other networks, you don't need to make any calculations. I don't need this. And I know that, okay, next is starting at what? 48. That means where this will end? 47. This will end at 47. Now I don't need this also. Okay, now I don't need that guy also. And here I can directly design my valid IP addresses. 10.33. This will be 10. And even if valid IPs also you don't require, because I already know that, okay, 45 will be falling in this range. So directly I can say this is my network ID. This is my broadcast address. Is it clear? This is what? Network ID. This is will happen. This will be fast valid IP. Now this will be broadcast address. This will be mask. So the approach is clear to everyone? Yes or no? Clear to everyone? Online people? Yeah, only host. Block size will always come from host bits. Okay. All right, let's take a different type of example. If I say okay, now what? Okay, see here. In this case, what will happen? Network bits 20, host bits 12, subnet mask 8, 16. This will be subnet mask constant. This is also network, so it will be constant. Network as well as host. And this is completely host. We just care about one octet, which is our interesting octet. So here, which octet? Which octet will be interesting? Third one. Correct? Now, again, same approach. Third octet, block size. So what it will be? 2 per 6. Oh. In the third octet, how many host bits? 4 only, right? Sorry. So this will be block size 16. Now what? Design the first network. These two are constant. This value is 0. And since host is there, so host will always be 0 in the network ID. Next network ID. So what is your block size? 16. Add it in your interesting octet. Now what is my value in the interesting octet here? It will already come in the first value. I don't need this. But based on this, first of all, I will know that, okay, if this is starting at 16.0, this one will end at 15.0. 255. Correct? Then I don't need it. Now I can start designing my valid IPs. Understood? Just your method should be correct. And your focus should always be there on the interesting octet. Other than that, nothing is required. Network ID, first valid IP, last valid IP, and the broadcast address. Is online people clear?
Yes, sir.
Okay. So always just focus on the interesting octet. The rest of all the answers will be there. Now let me tell you a trick. Okay. 3 steps are there. What are the 3 steps? First of all, calculate your interesting octet, find out the block size of the interesting octet, and then find out your network. Only 3 steps. Okay. Now I will not make this much of calculations. So what I'll do here, let's say one IP address is given to you 10.11.12.30 and slash, let's say 29. Okay. Now based on 29, I know that which octet is my interesting octet, fourth octet, because at least I can know that, okay, if between 1 to 8, first octet, between 9 to 16, it will be second, between 17 to 24, third, and after 24, it will be fourth octet. So directly I'll say which octet, fourth octet. And if I directly calculate fourth octet block size, so how many host bits in the fourth octet? 29, that means 3. So 2 part 3, because total 32. Out of 32, 29 is what? Network. So remaining 3 is what? Host. So this will be what? My block size? 8. So in the fourth octet, my first value will be what? 0 in the fourth octet. Then what will be the next value? 8. Then 16. What is my value here? 13. That means it will fall between 8 to 15. Right? So that means what will be my network ID? 3 octets I need to keep constant. Dot 8. This will be my network ID. And 10.11.12.15 will be my broadcast address. Because since fourth octet is interesting, that means before fourth octet, all are network. This way you can calculate. Is it clear? Okay, let's see. I'll give you one example. Same IP address. Okay, but let's say slash value given to you is 22. Give me the network ID and broadcast address. 255. In broadcast address, host part will always be maximum. In broadcast address, host part will always be maximum. Done. What is the answer? Mhm. Dot 31. Yes, what is your answer? Hmm? No answer. Confused. Yes, I'll explain. That's why I'm asking, right? See here. Yes, it is. See here. Slash 22. That means 8, 8. Then how many? 16. 16 plus 6 here and 2 host bits. And then these are all host bits. Correct? Which octet interesting? Third octet. Third octet block size will be 2 per how many host bits here? 2 will be 4. So that means in the third octet, see, first is constant 10.11. This is constant first two. Now value will be 0. Then next one will be 10.11.4. Then will be 8. Then will be 12. Then will be 16. So if this is 12.0, this will end at 15.2551. Got it? Or confused? It's okay. You can ask. Confusion is there? How? Like, what is the confusion? See here. We always do what? We keep the network part constant. Host part, we will start from 0. So always it will come from 0. And here we are all having host bits. So this also we will start from 0. Now, what is my block size of the third octet? 4. So in the third octet only, I will keep on changing value. Other octets, I will not change. 0. This will become 4.0. This will become 10.11.8.0. This will be 10.11.12.0 like that. And this will be what? 10.11.16.0. So if my this network is starting at 16, last one will be ending where? 15.255. So what is the value in your third octet? 12. Where it is matching? Here. So that means this is your network. So the first IP, it is your network ID. Last IP, it is your broadcast address. Is it clear? Now clear? Okay, let's do one more example. Let's say one IP address. This is given to you. network part, in a network ID, host part is minimum. And in a broadcast address, host part is maximum. So your host octet, that is your fourth octet. That will be 0 in the network ID and 255 in the broadcast address. So now what is the answer? 1.2.16.1.2.15.0. Block size is wrong. Hmm? What is the block size? 64. Correct. So that means first network 0, second is 64. So this will fall in the first range itself. Why not? Interesting octet is third octet. Value is 45. See here again. Here what is given to you? Slash 18. 18 means what? 1, 2, 3, 4, 5, 6. Okay, let me just go like this. CIDR is given to you what? Slash 18. According to this, then 2 here. Then interesting octet, third octet. So third octet block size, it will be what? 2 power 6, which will be 64. You will design your first network. So we all know that here, this is what? This is my network. This is my network. This is my interesting octet, which is containing network as well as host. This is my host. Correct? So I'll design my first network. So network part I'll keep constant. How many octets? 2 octets. So 172.16 I'll keep constant. Then my interesting octet I will start from 0 and host will always remain 0 in the network ID. Now in my interesting octet, I will keep on adding the block size. So next block size is what? 64.0. So my third octet value is what? 45. It is already falling in the first range, right? So means what here? That this will end where? 63.255. And before this, I will have 254. And here I will have. Okay, we don't need to calculate these valid IPs also. Okay, all we need is what? Your broadcast address and network ID. These are the two things we need. And this is also now not required. So this first one, it is your network ID, and this is your broadcast. Now is it clear? Clear, right? Okay. Note it, or you're just writing it down? Note it down. Hmm. Doesn't matter. Host part will remain 0. Host part minimum means what? Network ID. Host part maximum means what? Broadcast address. How many usable hosts in the last example? See, if you want to calculate total number of IP address, then you will have to consider all the host bits. So how many all the host bits are there? 6 plus 8, 14. So 2 raised to power 14 will be your valid IP addresses. That means total number of IP addresses. Okay. Is it clear? But if you are asked about network ID and broadcast address, in that case, just interesting octet. Okay. So here this is what? 16 0.0. Okay. Let's go with one more example. Please look at the second octet value. Done. How come 173? Correct. Simple addition mistakes you are making. Hmm? That is correct. Yes. Total number of networks not required here. Hmm? If it is asked number of borrowed bits, if total number of network is asked, so here, see, first of all, here we cannot calculate total number of networks because we are not breaking down, we are adding up networks. Okay, that is the reason. If you are going down below 24, then you will be breaking down. Okay, so you can help them if they need. Yes, done. Done. Correct. Correct. Good. So what is the network ID? Same. 192.168.0.0, 192, 171.255.255. Is it correct? Or still getting confused? Still getting confused. See, guys, you are using pen and paper. I'm not even using, right? See how it will be. Slash value is what? 14, 8, 6 plus 2, all host, all host. Forget about it. This is all network. Okay. Here, how many host bits? What will be the block size of second octet? 4. In the second octet, I'll have first value 0. Then I'll have 4, 8. Somewhere it will come 40, 80. Like this, it will come 160 also. 164, 168, 172. Got it? So first octet you need to keep constant. What is my first octet? 192. This value is for second octet. Interesting octet value. Post part, we will keep it 0. Now, if next one is starting 172, this will become 171.255.25. How simple it is. Got it? Online people? Understood? Okay, let's do one more example. Today we'll have brain exercises. Let's say less value should be something interesting. Your subnetting approaches are going right, but you're making mistakes in addition. So you must know how to do it, right? And you don't have to write all the values. You just have to find the nearest values. How you can find the nearest value? Just divide it with your block size. And what is the value coming nearby? So like 202. What is the nearest value that will get divided by 4? 200. So 200 will become your network. And after 200, next thing will be what? 204. So 203.255 will be your broadcast address. Got it? Otherwise, if you will start writing, your notebook will fill up. So this will be 200.0 and 203.255. This is clear. If these values, you can try, you can just divide this thing with whatever the interesting octet value is. You can divide that with your block size. If it is going too high, you can divide it with your block size and you can find out what is the nearest value getting perfect division. That will become your network ID. Is that clear? Hmm? Why? Tell me what is the confusion. If you are getting confused like this, your block size is 4, this thing is clear to you, right? Block size will be what? 4. You'll start from 0, 4, 8. So 10 times will be what? 40. 20 times will be? 30 times will be? 40 times? 50 times? Now you got 200. Next will be what? 204. This is clear. So many ways are there, right? There is no long method. There is no short method. Only one approach. If it is small digit, you can do it. Let me give you. Let me give you one interview question. Okay, this is asked in the interviews. Let's say. Now do it. This value is small. If your approach is correct, you will get the answer. Already confused. If block size is smaller, then how can we calculate network ID in broadcast address? Easier way how to reach the exact network. So like I said, you if the number is larger and your block size is smaller, just divide the number with your block size. Like what we did here, right? That here your block size in this case was what? 4 and your number was 202. So what do you do? Divide it with 4 and just try to find out that okay, 202 is not perfect division. But if it was 201, still not. If it was 200, now it is perfect division. So that means 200 will be my network ID. Or else you can calculate like that, 10 times 40, 20 times 80, then 120, 160, 200. These ways you can calculate. Yeah. So hmm, broadcast address, still find out. Okay. Yes. What is the network ID? What is the broadcast ID? Okay, right or wrong, at least tell me. Doesn't matter. Can put it in. What I said, do not leave your approach because this creates confusion. That's why interviewers give this kind of question. No. Mhm. What is your answer? Your answer? Here, block size, sorry, network ID will be H, and this will be not 0. Here, your block size again what? If you see in this question, okay, and in this question, as well as in this question, there is no difference. Why? Everywhere your block size is coming 4. Just the octet difference is there. So in the first octet, your first value 0, 4, 8, 12. What is the value? 10. So 11.255.255.25. 8.0.6. Question is same. That is why I always say, focus here. Don't come here. Just focus the value here. What is the value? Eventually, this is same question. Here is also 4 block size, but in a different octet. Here also 4 block size, but in a different octet. So octet, let it change. Doesn't matter. Stick to your approach. Clear? Online people? Okay. Let's say 22 dot. Okay. 128, 121, 122 dot 128.0. Your number is 123. Where you are going network ID? 121 watt. Yes. 121 watt, 123 watt, 54. If you start at 64, 64 plus 32, 96 only. Still it is 123. 120. Block size is 32. How come 120 will get divided with 32? Thirty-two, right? 32. Block size 32. According to me, 32. I don't know what you're calculating. Broadcast. Still make mistakes like this. How it is going to work. So I believe now it's clear, or still there is doubt. See, you will need more practice over it. So for this thing, what I'll do, I'll drop some questions in the drive. You guys practice them. You have entire weekend. Anytime you face a doubt, you drop it in the group. We'll discuss. Okay. And if you want that, okay, there's a question that should be discussed with everyone. So I'll discuss them in the class itself. So 2 days you have for practice. Okay. Clear online people? All right then. So I'll be uploading the questions and let's find out. This notepad also I'll share in the drive. Okay, guys, then see you on Monday. Have a great weekend. Thank you.